Jonas, welcome. Jonas Jensen is a sustainability specialist working at Siemens Gamesa Renewable Energy. He has an educational background as Master of Science in Environmental Engineering and PhD in Circular Business Models, both from Aalborg University. Jonas has spent the last 8 years working for Siemens Gamesa and has been involved in recycling projects of wind turbine blades and development of the newly developed Recyclable Blade. Jonas, the floor is yours.
Thank you, and thanks for hosting this event and for inviting me today. So yes, as you just said, I will give you some of the perspective from Siemens Gamesa on decommissioning and recycling of existing blades, but also put a bit of lights on our recyclable blade. Yeah. So I think the broader picture is more or less clear for most now that all the steel parts from a wind turbine is under control from a recycling perspective. When we add up all the materials that we put into a wind turbine, all the energy spent on creating these materials, all the energy spent on installing, servicing the wind turbines and recycling those, what we see is a really low CO2 footprint of wind energy. What we call life cycle assessment shows that the CO2 footprint of a kilowatt hour from wind is between 5 and 15 grams of CO2 per kilowatt hour. That is in contrast to the world average for electricity of 475 grams and fossils in the upper range of 800 grams per CO2 per kilowatt hour. So we already come in what we call our footprint from a really good point of view. Then, of course, ambitious as we should be, we want to increase the recyclability of our products to the largest possible degree. That means that we have to focus on the composites. And that will be the topic of what I will show you now. So just to show what Alexander showed before in another diagram, there are multiple recycling concepts or disposal concepts for blades. There's the disposal route of landfilling. So basically putting the composites as an inert material there so it will not leak anything to the external environment. So it's a temporary storage of carbon emission if you want so. But of course, the ambition level should be higher that we utilize the resources that we have spent energy creating so we also reclaim these. What is happening, as Alexander also alluded to the large degree in Europe, is that the blades will be chopped up, shredded into relevant sizes, and then fed into cement co-processing. Then the resin will replace the fuels for this, and the glass fibers primarily will replace sand or silica for the process. So you get some sort of use. Reuse of blades, or what we call reprocessing, is actually more lifetime extension project, right? So using some of the properties of composite, which we know are good, lightweight, durable, all these, to second application before eventually needing to recycle. And then what have we tried there? For recycling, many things. Tried different structures, tried to make furnitures like tables that you see here, pick fences for stables and barns. We have made scooters that we even got the Crown Prince of Denmark to try, and other applications of the threaded material that Mie also showed, tried to cast that into new application. It can also be pyrolysis, so gasifying or getting an oil out of the resin and then fibers out that can be used for various purposes. The last thing is the chemical recycling, using acids, temperatures, and pressure to to separate. So looking at the pictures, it all looks nice. There are plenty of possibilities. So what are the remaining challenges, one could ask? I think me also somehow alluded to it. One thing is to find the technology and make that cost efficient. What is also needed for cost efficiency is that you need volume. And that technology and volume needs to be coupled with a business model. So we as OEMs are not world champions in recycling. We are not world champions in connecting secondary material to the use applications. So I think there is a market need for further optimization of this, where the use of secondary material into primary production is needed. We have been part of several projects trying to demonstrate technology, trying to demonstrate solutions, and trying to demonstrate um, value chain. So Genwin project, mainly out of Denmark, Live Brio project, EU funded, fiber reuse project, all advancing the technologies. As me also told, we are now part of the Decom Blades project, where we as an industry are working together to combine the technology with the volume, with the business model. So how can we as an industry help facilitate that these technologies I showed on the previous page are actually being used, so we lower the environmental footprint even more, so we lower the cost of recycling, and so that we get interesting products out of the blades, of the composites, after they have been producing clean electricity for many years. All these projects, of course, also give learnings to how can we do it better for the future. So taking these learnings in designing for recyclability, we have now launched what we call our Recyclable Blade. So the background for launching the Recyclable Blade is that we as a company have committed to have fully recyclable blades by 2030 and fully recyclable turbines by 2040. We have been supporting the Wind Europe call for landfill ban, so we want to drive the volumes of composite into recycling industries. Yeah. So the recyclable blade has been a journey where we have now produced and are producing the first blades for commercial projects. So the first blades rolled out of our factory in Denmark, Aalborg, the start of 21, and the first projects using the recyclable blades will be installed in 22, and then we expect to have be ready to offer full projects from 24. The first projects will be installed in Germany, but it's not limited to any geography. So what is the recyclable blade? It is a blade that is, from a property point of view, strength-wise, service-wise, exactly the same as our normal blades. But we have now configured the chemistry so that it can be dissolved after being decommissioned, and then the materials can be reused. So it has been a project that was concepted in 16, then active project since 2018. It has included resin development, testing of the resin, and recyclability testing, then qualification of that material, and then full-scale production and soon to be installation of these blades. So what is the process able to do? What you see on the second part is a blade tip being lifted from this steel container, where we have a mild acidic solution. So it's basically the same process as making pickles for your burger. So you put the blade into the acetic acid and then elevate it to below 100 degrees for a couple of hours. Then you would be able to separate the resin from the fibers and the core materials. these need to be rinsed, and then the materials can be recycled into new products. The interesting part here is that the resin becomes a thermoplast, so it will be possible to use it as a plastic that you can heat up and mold. Use that for some cycles for various products, and when that has been done, it can be chemical recycled into the base components and made new blades out of it if needed. The recycling process is really mild, so we only see a 2% decrease in the strength of the fiber material, and also low energy consumption, which means that you also drive down the cost of the process and up the value of the materials that comes out of the blades. So the blade this is now tested by us and by our partners, the Danish Technical University, and by our resin supplier. It has gone through all the mechanical, static tests, fatigue tests, health, safety, and environmental evaluation, and so on. So fully compatible with our products, ready for the market. So we believe the future is recyclable. We believe this is a good first step towards a fully recyclable blade and a fully recyclable turbine. We also believe that it can help lower the environmental cost of the blade, but also the financial cost of the blade when you have to take care of it when the turbine has been producing clean energy for many years. And it's a really simple process that should be able to be performed close to the wind farm, so no big logistic concepts are needed. And using environmental impact assessment also shows a decrease in the environmental footprint by the fact that you are able to re-enter the materials into the material loop. So the resin as a plastic, the fibers as fiber application. So I think there's progress, technology development can be said both on the existing blade fleet, but especially also for the blades that we will produce going forward. Thank you.
Thank you, Jonas. We have some questions from our audience, but I will make to all of you during the end of the